you missed something or if you're not sure about an example, please feel free to rewind it and rewatch it at any time. So we're going to start by making our foldable. For this foldable, we will need 3 sheets of paper. So at this point, you can stop the video, you can pause it, and label all the parts of your foldable. Now that we are in the first section, we are going to talk about a monomial. A monomial is a number, a variable, or the product of a number and one or more variables. Monomials cannot have addition or subtraction. They cannot have negative exponents on variables, which also means the variables cannot be in the denominator of a fraction. And you cannot have a square root on a variable. Again, please feel free to pause this so that you can write down all of this information. Determine whether each of the following is a monomial. So what I want you to do right now is pause the video, write these down, give it your best guess using the rules from above, and then we will compare our answers in just a second. Okay, looking at number 1, 5b. 5 is a number, b is a variable, and 5b means that they are being multiplied. So yes, that follows all of the rules for a monomial. Negative w. Negative w is -1, a number, times w, a variable, and yes, that follows the rules of a monomial. The next one is x plus 5. X is a variable, 5 is a number, but we're not multiplying. We are adding these numbers together, and the addition is not allowed for a monomial, so that one does not qualify. X squared. X squared really means x times x. Since x is a variable and we are allowed to multiply them, x squared is a monomial. The next one is a to the negative first. A to the negative first has a -1 exponent on it, and we are not allowed to have negative exponents. So no, this one does not qualify. And our 6th example is 3 over n. And again, n cannot be in the denominator, so no, this is not an example of a monomial. Now we're going to look at some of the properties and how to work with things that have exponents on them. So my first example is negative exponents. A negative exponent, when it's applied to a variable or a number, moves that part of the fraction to the other part of the fraction. So if a to the negative n is on top of a fraction, think of this as being a to the negative n over 1. To turn that negative exponent into positive, I have to move it to the bottom of the fraction. Likewise, 1 over a to the negative n, since it's already in the bottom of a fraction, to turn it positive, I will move it to the top of the fraction. But we don't have to write either of these ones. It's just showing how they relate to fractions. So here are 2 examples for you to try. Please pause the video and try these, and we will compare in just a second. 2a to the negative third is the same thing, if we want to get rid of that negative exponent, as 1 over 2 to the third. Well, 2 to the third can be simplified since 2 is a number, so it's going to become 1 over 8. The second example is 3 over b to the negative 8th. The 3 is fine. It's positive exponent, so it stays where it is. However, the b has a negative exponent, so it's going to go from the bottom of a fraction to the top and become b to the 8th. And the only thing that we have left on the bottom is 1. So I can simply write this as 3b to the 8th. Right? My next properties are how you use a product of powers. So on this example, I have a to the m times a to the n. Both of these bases are the same, and that's a key part. We can only talk about these rules when our bases are the same. So when you multiply like bases that have exponents, you end up adding the exponents. So in this first example, we have 4 to the 2nd times 4 to the 9th. The base has to stay the same, just like up here, my a times a. The multiplication is actually going to be taken care of in the exponents. So I'm going to have 4 as my base, and my exponents are going to become 2 plus the 9, which is 11. And when I rewrite this, I can make it 4 to the 11th. But since this is a number, it can be simplified even farther, and it will become 4194 304. Right? So that would be the answer that I would want you to write down. Now, the fact that some of these problems have letters in them actually makes the problem a little bit easier because you don't have to use a calculator to come up with such a large number. If I have b to the 3rd times b to the 5th, my base, once again, is going to be b. And when I add the exponents, I simply get b to the 8th. And since b is a variable, I leave it like that. My next example is quotients of powers. So it's similar to the multiplication, but it's the opposite. You're going to take, as long as these have the same base, a and a, instead of, like when we multiplied, we added the exponents, when you divide, you're going to subtract the exponents. So a to the m divided by a to the n is going to be a to the m minus n. So once again, pause the video and try these examples. 5 to the 3rd is 5 to the 3 minus 1. Well, that simplifies to 5. 3 minus 1 is 2, so 5 squared. And this one is a much smaller number than before. 5 squared is 25. My next example, x to the 7th over x to the 3rd is going to become x to the 7 minus 3 is 4. So it's simply x to the 4th. And then we come to our 3 final properties. Power of a power. What this means is if you have something to an exponent and you're putting another exponent on it, you are going to simply multiply those exponents. If you have two things that are being multiplied together, a power of a product, and then you are putting a power on that, you can think of this as being the distributive property. It's not the exact same, but you're going to take this exponent of m and put it on the a, and you're also going to put it on the b. So it's a to the m and b to the m. And finally, you have a power of a quotient. So once again, you're going to put the power of n on both parts of the fraction, or any letters that are inside those parentheses. So, once again, pause the video and try these examples. A squared cubed becomes a, and when you multiply 2 times 3, you get 6. The next example, x times y to the 7th becomes x to the 7th, y to the 7th. A cubed, b cubed is the answer to the next one because you have a over b both being cubed. And the final example, you're going to take x over y to the negative 4th. So you're going to take x to the negative 4th, and you're going to take y to the negative 4th. But that's not simplified, because both of those have a negative exponent. So this is going to move to the bottom and become x to the 4th. And my negative exponent on y is going to move it to the top, and it's going to become positive. So to completely simplify this problem, it's going to be y to the 4th over x to the 4th. Right. And now, I definitely want you to pause the video, try these examples, and then we will compare our answers. The hardest part, I think, for students in the past has been, after we talk about these exponents, to go back and talk about regular numbers. 3 is a regular number. Negative 4 is a regular number. Those get multiplied. 3 times negative 4 is negative 12. X to the 3rd, x squared, is going to be x to the 5th. And y squared times y to the 4th is going to be y, when you add those exponents, 6. My next example is going to be x to the 9th over x to the 5th. So I'm going to, because I'm dividing, I'm going to take these two and subtract the exponents. So it becomes x to the 4th. The next example is the same as before. I have b to the 3rd over b to the 8th. When I subtract those exponents, I get b to the negative 5th, because 3 minus 8 is negative 5. However, that's not completely simplified. So to get rid of that negative exponent, I need 1 over b to the 5th. The next example, I'm going to apply an exponent of 5 to everything. So negative 2 to the 5th is going to be negative 32. A cubed to the 5th is going to be a, when you multiply, you get 15. And b squared to the 5th is going to be b to the 10th. My next example, I'm going to take each part and apply the power of 4 to it. So negative 3 to the 4th is going to be 81. X to the 4th stays x to the 4th. And on the bottom I have y to the 4th. My next example, I'm going to do the same as above, except I'm going to apply a negative 3 exponent to everything. So that is a to the negative 3rd over 4 to the negative 3rd. Just like in a previous example, both of these have negative exponents, so I need to essentially flip the fraction. So a to the 3rd goes to the bottom. Notice that that exponent turned positive. And then on the top, I get 4 to the 3rd. And since 4 to the 3rd actually works out to be a number, which is 64, I'm going to put 64 over a to the 3rd. My final example, I'm going to take everything and apply an exponent of 4 to it. Negative 2 to the 4th is 16. X to the exponent of 3n to the fourth. When you simply multiply those exponents, you get x to the 12n. On the bottom, x to the 2n to the fourth is going to be x to the 8n. And then y to the negative third is going to become y to the negative 12th. Now this requires some simplifying. 16 is the only number that I have, so it stays by itself. I have x to the 12, and I forgot my n, over x to the 8n. When I subtract those exponents of 12n minus 8n, I get x to the 4n. And then to get rid of this negative exponent, I'm going to move y to the top, and it's going to become y to the 12th. All right, so I hope if you have any questions that you will ask, or if you need to review or try any of these examples, please feel free to rewind the video and do so. Thanks.